Hello everyone, my name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 is to draw the Lewis structure of NO2 minus. Okay. Give me 1 second. Okay, sorry about that. My pen died, so I'm just charging it now. So, the Lewis structure of NO2 minus. So when we write the Lewis structures, we first have to find out the total number of valence electrons. In the case of nitrogen, nitrogen has 5 valence electrons. And in the case of oxygen, each oxygen atom contains 6, and there are 2 oxygen atoms, so we multiply this by 2. And also this is an ion that has a -1 charge, so I need to add an extra electron as well. So if we add this all up, we have a total of 18 electrons. So now I'm just going to rearrange my atoms so that nitrogen is in the middle as our central atom. And then I'm just going to draw 2 bonds to oxygen on either side. Okay, so at this point, I would try to write in all of the lone pairs on my terminal atoms. So in this case, all of the oxygens. And to have a full valence shell, we would need 3 lone pairs in total. So notice that nitrogen still does not have a full valence shell. So instead of making both oxygens single bonded, I'm going to make one of them double bonded. And at this point of drawing, I just like to see how many electrons I've drawn down so far. So if we recall that each bond contains 2 electrons, and we have 3 bonds, I have so far drawn 6 electrons participating in the bonds, and now I'm just going to count on my lone pairs. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I need 2 more electrons, so the last 2 I'm going to put as lone pairs on my nitrogen. Okay, so now that I drew out this structure, I want to find out all of the formal charges for each of these atoms. Let's do this down here. So formal charge will help us see, obviously, what charge each atom would have. And its equation is the number of valence electrons minus the number of non-bonding electrons. So these are all the electrons in the lone pairs. And lastly, the number of bonding electrons divided by 2. Okay, so I'll label the 2 oxygens 1 and 2. So let's calculate the formal charge of the first oxygen. Formal charge of oxygen 1. So the number of valence electrons in oxygen is 6. Its number of non-bonding electrons is 4. And its number of bonding electrons, so there are 2 double bonds. So we have 4 in total, and this is divided by 2. So 6 minus 4 minus 2 is equal to 0. So now let's look at the formal charge of nitrogen. So nitrogen has 5 valence electrons. The number of non-bonding electrons nitrogen has is 2. And there are 3 bonds to nitrogen, so there are 6 bonding electrons divided by 2. So 5 minus 2 minus 3 is also 0. And now let's look at the formal charge of our last oxygen. Again, oxygen has 6 valence electrons. This oxygen in particular has 6 non-bonding electrons, and there's also 2 bonding electrons in that single bond. So the formal charge of the last oxygen is -1. So I just need to write a charge on this one oxygen. And this is one of the resonance structures of NO2. And I can draw a second one with the other oxygen. With the leftmost oxygen now carrying the negative charge. Okay, so these are the 2 Lewis structures of NO2-. And the junior tutor said that the Lewis dot structure represents the arrangement of electrons, shown as dots, between atoms in a molecule. Atoms must follow the octet rule, or the tendency of atoms to prefer to have 8 electrons in the valence shell. The individual formal charge of each atom, as well as the overall charge of the molecule, must be satisfied. In drawing the electron dot structure of NO2-, we first draw the skeletal structure. with the nitrogen in the middle. Nitrogen is less electronegative than oxygen. And also we kind of can estimate which atom is the central atom just because there's only one of it and there's two oxygens. Step 2 is to calculate the total number of valence electrons in the molecule. So we did this first, but it doesn't really matter what order you do the steps in. Step 3, distribute the electrons as dots. Step 4, to satisfy the octet rule for the nitrogen, a pair of electrons from one oxygen must be transferred. Step 5, replace the shared electrons with bonds. A lone pair of electrons will be left at the top of the central nitrogen atom. And step 6 is to determine the formal charges in each atom. And they got 0, 0, and -1. Okay, so this solution is correct.